In my experience as a math teacher, the arc length formula gets messed up all the time. So I'm actually not going to teach it. I'm going to show you kind of how it works and the fact that it really isn't even that necessary that you know it in the first place. So here's a problem. It says that we have an extension cord that's being wound around its holder, which has a radius of 0.9 feet. And if we wind it up by rotating it 97 degrees, how many feet of cord did we wind up? So it's all circular. It does say that we have a radius of 0.9 feet and that we wind it up by rotating it 97 degrees. So let's go ahead and get an angle in there that's about 97 degrees. Not quite 97, it's a little more, but it doesn't have to be to scale. And they want to know how many feet we wound up. Well, that's just going to be this length right here. Well, what is x related to in this circle? Well, it seems like it's a piece of the circumference. So if we can just figure out how much of the circumference, we should be good to go. So the way I'm going to define arc length is that it's just whatever fraction or percentage or portion of the circle we have times the whole circle. And that should make sense to you. If we had a circumference that was 4 feet and we wanted half of the circumference, if we want half of the circle, half of the circumference, well, we just multiply those together, right? This is a pretty common thing. It's a portion or the ratio, the percentage of the circle, really. We know pretty easily how to find the whole circle length. That's just called the circumference. That's just 2 pi times the radius, or 0.9 feet in this example. And then the portion of the circle, well, how could we figure out how much or what fraction of the circle we have? Well, we know we have 97 degrees here out of a total of 360 degrees. That's the portion of the circle we have. So then we can just multiply all of those together, and we're going to get that our arc length here, or x, is just equal to 0.485 pi feet. Well, that's a nice accurate answer, but it probably isn't the most useful here to know our answer in terms of pi, so we can go ahead and approximate our answer out to 1.5 feet. And again, I use the approximate symbol here because we're basically admitting that our answer is technically wrong, but it's going to be more useful in this form. The reason I like this strategy is it allows us to just kind of use a generic idea, which is if you want a portion of something, you just multiply it times that fraction. And we're going to see that that works really well for area as well.